All right, everybody. So, going to do a quick video on exponent laws and then one more video on scientific notation after that. So, there's a lot of different exponent laws, and many of them make sense if you just think back on what an exponent means. So, let's look at just a quick example. Something like 2 to the fifth means you write down the number 2 5 times. So, if you look at an example like 2 to the fifth times 2 to the third, you're going to write down the number 2 5 times, and then you're going to write it down 3 more times like that. So here's the first 5 of them. Here's the next 3 of them. If you count all those up, you get 8. This can get really annoying if I asked you to do 2 to the 15th times 2 to the 32nd. Nobody wants to watch a YouTube video where I write out all those 2's. And so you start looking for a shortcut. Well, if I write out 15 of them and then 32 more of them, I can just add them up together as a shortcut. That's how many they're going to be total, leaving me with, I guess, 47 of them. So when you see the exponent law that looks like this, x to the m times x to the n, that becomes x to the m plus n. And the idea there is just you are counting up the total number of x's all in a row, and so that's going to be adding them together. And the reason that I switched from a 2 to an x is because this argument that I made wasn't really specific to the number 2. I could have done it with a 12 like this. I could have done it with a 4 like this. Just changing all my 2's into 4's. And the same argument makes sense. So as long as the bottom number matches and you're multiplying, you can add the tops. Really similarly, if we have something like 3 to the fifth divided by 3 to the second power, and we write it out, there's 5 3's on top, there's 2 3's on the bottom. 3 divided by 3 is 1. So how many are left over? 3 3's are left over. That's okay with a small number of factors, but if we had 4 to the 17th over 4 to the 12th, I don't want to write all those out. But what I notice is that each of the tops cancels a bottom, leaving me with just the difference between the two. So I can shortcut it and just write 17 minus 12 and write it as 4 to the 5. That's what it means when it says an integer raised to a power. You have a single integer raised to a single power. One of the weird ones that is tricky for people sometimes is the idea of a zero exponent or a negative exponent. Let's look at a zero exponent first. One way to think about this is just to look at patterns. So let's look at 5 to the third, 5 squared, 5 to the first. So 5 to the third just means 5 times 5 times 5. This just means 5 times 5. This just means 5. Turns out that this is equal to 125. Turns out that this is equal to 25. And as I go down the list, every step that I go down the list makes me divide by 5. 125 divided by 5 is 25. 25 divided by 5 is 5. So what number has to come next for 5 to the 0? Well, if I go down the list, I divide by 5. So 5 divided by 5 has to be 1. Another way to think about that is I didn't write down any 5's. The exponent is the number of 5's I'm writing down. So when I have 5 to the 0, I don't write down any 5's. Now, how can I write down negative 1 5's? Well, the pattern is as I go down the list, I divide by 5. So I take 1 and I divide it by 5. It's kind of nice. I'm writing down a 5 because I have a 1 in the power. It's not a positive 1, so it's not a multiply by 5. It's a divide by 5. That's why it's on the bottom of the fraction. 5 to the negative 2, 1 over 25, 5 to the negative 3, 1 over 125, etc., etc., etc. So in general, what I hope you notice is that if you have a negative power, it's the same as a positive power, just underneath a 1. So then where it gets a little tricky, I'll just do one example. Where it gets a little tricky is when you have multiple things all kind of together in the same problem. Something like this. So the only times I can add powers together or subtract powers from each other is if the base number is the same. So I can't really do anything the way it's written. What I can do is write this as 2 to the fourth times 3 to the fourth, and then copy the 2 to the third and the 3 squared. Then what I'm going to do is I'm going to look at the two different powers of 2. Those have the same bottom number. So they're the same bottom number, so that number is going to stay the same. 4 plus 3 makes 7. Then I'm going to look at the two different powers of 3. Those have the same bottom number, so it's going to stay the same. And I do 3 to the 4 over 3 to the 2. That means 4 minus 2, which becomes 2. Wrote the wrong thing there. So that becomes 3 to the second power like that. Okay, so in general, if the base number matches, so if it's like b to the 5 and b to the 7, then your answer is going to be b to the something. It's going to be b to the 12 in this example. And sort of similar, if you have like the top number matching, like 5 to the 3 times 4 to the 3, then the top number is going to be the part that survives, and you can multiply the bottom numbers together. So when you're looking at your exponent laws, I encourage you to either write them all out or to look for which ones match. So are the base numbers matching or are the exponents matching? And just do some practice. There's more practice than you could possibly want to do if you just Google the words exponent laws. So please comment or ask questions if there's anything else I can do. Happy to help.